Welcome back to my today's session on electromagnetic field. Myself Dr. Sayanti Chatterjee, Associate Professor of IARE College, Hyderabad, and today my topic is the polarization. So what is the meaning of polarization? Polarization means we are dividing any plant or any field into the small parts. This is called the polarization. In this chapter, in this today's topic, we will discuss about the polarization of the electric field and magnetic field. Electric field, the polarization is due to the static charge, and in the case of the magnetic field, we will discuss the polarity about the magnets. These magnets may be two types, either permanent magnet and electromagnet. We will mainly focus on the electromagnet. And in the case of the electric field, what is the meaning of the electric field? Electric field means this is the area where if we keep any other electrical charge, it will experience a force, and we can tell the electric field intensity E is equal to electric field intensity can be written as the Q by 4 pi epsilon r square. What does it mean? It depends on the permittivity of the medium. It always depends on the permittivity of the medium. So Q is the amount of charge, epsilon is the permittivity of the medium, and r is the distance on which the electric field we are measuring. What is the meaning of magnetic field? Magnetic field or magnetic field strength depends on the, as we are thinking about the electromagnets, it depends on N into I, number of turns into the current. Sometimes we can write the number of turns per ampere turn per meter. And electric field can also be written by B is equal to mu H. What is mu? Mu is nothing but the magnetic permeability. So epsilon is permittivity and mu is the permeability. Polarization, in this chapter, we will discuss the polarization of electric field and magnetic field. And is the first part of this topic, we will discuss about the polarization of the electric field only. So, first we will discuss about explain the formulation of dipole in the electrostatic fields. So first we have to understand what is dipole. So first, dipole is nothing but I am giving one example from chemistry, and this is the dipole. Say we have an H2O. So what is H2O? Water. And H2 has 2H plus O minus. We know H2O can be written as 2H plus O minus. So we can think that the H2O is this type. It looks like this. H2O looks like this. If we connect the water, if we keep the water particle in a electric field, it will change its shape. The plus will be attracted by the negative, and the negative oxygen minus will be attracted by the positive. And as a whole, it will elongate its shape. The H2O will be changed. The H plus will be, this H plus ions will be accumulated on the one side, and oxygen minus, the negative, will be accumulated on the another side. This is called the dipole. We are dividing one atom into two polarity, and this is called the dipole. So what is the definition? An electric dipole is formed when 2 point charges of equal magnitude but opposite sign are separated by a small distance. So what is this? This is called a dipole, and this is called the polarization. Now what is dipole? Dipole means, say we have 2 point charge. Here we have taken plus QE and minus QE, plus Q and minus Q. We have 2 charge, plus Q and minus Q, and we have shifted. This is one plus Q charge and this is one minus Q charge. 2 charge of equal magnitude but opposite in direction, and they are separated by a small distance, not big distance. They are separated by the small distance. This will create a dipole. When an electric field E is, as I told, H plus, oxygen minus O. But one thing we have to remember, equal magnitude. They have the equal magnitude. When an electric field E is applied to a positive charge, it displaced from the equilibrium position in the direction of E by a force of F plus is equal to QE. So what is happening? We have one, so again I am giving the example, we have one atom, it has the positive charge and negative charge. Now we are connecting it with a battery, so there will be an electric field. What will happen? The positive charge is displaced from its equilibrium point due to the force QE. Similarly, the negative charge is also displaced in the opposite direction. So if the atom is basically circular, if we connect the atom with a battery, it will change its shape. It will change its shape like this. So it will elongate. One side is the positive charge, another side has the negative charge. So this is called the dipole. This is called the dipole. When an electric field is applied, the positive charge is displaced from its equilibrium position in the direction of E by the force F plus is equal to QE, and the negative charge in the opposite direction by F minus is equal to QE. So again we can write, so this is one positive charge and negative charge, and both are in the distance, d distance between them. So the distance traveled by the point charge, is defined as the dipole moment. And mathematically, what is dipole moment of an electrical field? Dipole moment is nothing but the product of the charge and the distance. Dipole moment doesn't depend on the polarity of the charge. For occurrence of the dipole, we need the 2 charges of equal magnitude but in opposite polarity. But whenever we are planning for calculation mathematically, dipole moment doesn't depend on the polarity of the charge. It is the P is equal to Q into D, where P is the electric dipole moment, D is the distance between the charge, and the line of the two charge is connected together is known as the axis of dipole. This is known as the axis of dipole. A dipole results from the displacement of the charges, and the dielectric is said to be polarized. So when the charge is displaced, like this, when the charge is displaced and the circular form has been changed, we can change. The dielectric is said to be polarized. This condition is known as the polarized. In the polarized state, the electron cloud is distorted by the applied electric field. So this we can think this is the electron cloud. All the electrons, electrons are present there. So electron cloud has been distorted. The distorted charge distribution is equal to the principle of superposition, and plus so we can write it is the P equals to QD. For the different set of charges, we get the different polarization, and total polarization is the summation of the all charges. P is equal to Q into D. So define dipole moment and deduce its expression. A dipole results from the displacement of the charge, and dielectric is said to be polarized. So we are just making a small synopsis of whatever we have discussed. A dipole results from the displacement of the charge, and the dielectric is said to be polarized. In the polarized state, the cloud of electron is distorted by the applied electric field E. The distorted charge distribution is equivalent by the principle of superposition to the original distribution plus a dipole whose moment is P is equal to Q D. So if we combine these three equations, as this is a superposition theorem, limit delta V tends to 0, delta V means per volume, K is equal to 1 to N. If we have the N number of charge, we can write K equals to 1 to N QK dk. QK dk for each charge. So total polarity, total dipole moment of the system is Q into D. Next question is if there is the dipole moment, there will be some torque. So extract the expression for torque of an electric dipole in the electric field. So this example is very, very important. So we can get this expression in any motor and machine. Due to the electric dipole, we are taking some electric field. This is the electric field, and we are keeping one plus Q charge and minus Q charge, and we are taking the distance between them is D. So what is the force experienced by the Q1? Force is equal to E into Q. We are getting it from the Coulomb's law. So from the Coulomb's law, we can tell the force experienced by the positive charge is equal to F1 is equal to E into Q. Similarly, if we want to calculate the force exerted by the minus Q is equal to F2 is equal to minus E into Q. As I told in the previous slide that the force works in the opposite direction. The force works in the opposite direction. So what is the total force on this conductor? It is F1 plus F2 is equal to 0. F1, the total net force working on it equals to 0. But torque is not equal to 0. Though force is equals to 0, but we can tell torque is not equals to 0. Due to the force experienced by plus Q, what will happen? It will tend, as this is the getting one force plus Q, it will tend to come in the, it will try to oscillate, it will try to come in the equilibrium position. Similarly, minus Q will also try to come into the same in the equilibrium position, and which leads to the torque of the dipole. So net force is equals to 0. This is like this is positive and this is negative. Due to the force experienced by the charge, it will tend to come in the equilibrium in this side, and it will also come to force in the opposite side. As a result, at the midpoint, it will experience some torque, and this is known as the torque of the dipole. So what is torque? According to the definition of the torque, T is equal to magnitude. Remember, we are taking only the word magnitude, not the direction. So magnitude of force plus perpendicular distance, not the normal distance, perpendicular distance between their line of action. So we have to take the perpendicular distance. and we are taking the distance is from the equivalent point is D, and it is also in the D. So what will be the perpendicular distance if the angle is theta? So it will be a D, or we are writing R here. Okay, we took it R. So it is the R sin theta. Similarly, this is also R sin theta. So what is the total distance from one charge to another charge? The total distance is 2R sin theta. So torque is equal to, as we are taking the magnitude, E into Q by 2R sin theta. So what we got? The distance from the equilibrium point of to the plus Q is R. From the equivalent point to minus Q is also R. So what is the total distance? The total distance is 2R sin theta. Now, if we think about the Q into 2R, if we are taking the Q into 2R, what is Q into 2R? Q into 2R is known as the, what is the Q into 2R? Q into 2R is known as the dipole moment. So dipole moment P is equal to Q into 2R. We wrote here also. So we can write it as the Q into 2R is equal to P into E sin theta. So what is the torque? Torque we got T is equal to PE sin theta, where E is the field, P is the dipole moment, and sin theta is the angle between the, what is the theta? Theta is the angle between the work of the field direction and the axis of the dipole. Now illustrate the expression for the electric field intensity due to electric dipole. We will discuss about the electric field intensity due to electric dipole. One is plus Q charge, another one is the minus Q charge. So what is V1? V1 is equal to KQ by R1. As we know, it is the K. For one charge it is KQ. So it is KQ plus R1. This is our Q1 charge. So it is KQ by R1. What is R1? R1 is the distance from the Q1 to the XY point. And what is the value of R1? R1 is equal to root, if the distance is X, up to this is A. So it is X minus A. So X minus A square, if this point is XY, so this is Y. Up to Q is X. So X up to this point is X. So X minus A by Y. So we got the R1. Now if we write the V2. What is V2? V2 for this point. Again, how we are getting the voltage? Voltage is equal to E by R. What is voltage? Voltage is nothing but the E by R. So what is the V1? V1 is the KQ by root of X minus A square plus Y square. Now think about V2. V2 is in the opposite direction. So it is minus KQ divided by R2. Minus KQ divided by R2. Now what is R2? If this is the XY point, so from origin to this point is X. This is A. So this length will be, so now we are thinking about this circle. And what is the direction? If this is the X, from origin it is X. So this is A. So this total distance is X plus A. Height is Y. So what is R2? R2 is nothing but the X plus A square plus Y square. Sorry, this will be the R2. So what is the value of V2? V2 is minus KQ by root of X plus A square plus Y square. So what is the total V? The total V1 is this. V2 is this. So total voltage V is equal to KQ by root of X minus a whole square plus y square minus kq root of x plus a square plus y square. This is our total voltage V. This is our total voltage V. Now, if the R is very big, if the value of the R is much more greater than A, so we can substitute the equation like root of x plus A. This R1 we can write it by R square plus 2AX. We are just A square we are removing. X equals to R cos theta. We are assuming what is X? X is nothing but the R cos theta. Just we are putting the value. And if we simplify it, we can get V is equal to Kp cos theta divided by R square minus A square cos square theta. So what is the meaning of the polarization? Polarization is also defined as the electric dipole moment per unit volume. This can be known as the electric dipole moment per unit volume. If A is the area, cross-sectional area of the dielectric, I is the, or L is the distance, this is not I, this is L is the distance between them, they separated, and Q is the total charge, then polarization written by, polarization capital P can be written as the dipole moment per unit volume. What is dipole moment? Charge into distance is equal to A by L. So we can get Q by A. Polarization is, so what is the Q by A? Q by A can be written as the rho S. Surface charge, surface charge density. So numerically we can write that the polarization is equal to the surface charge. So what is the unit? Coulomb per meter square. Though it is only the mathematically, physically it is not equal or not, we can write the polarization in terms of the surface charge density. But numerically both are equal. What is the meaning of the dielectric constant? Dielectric constant is defined as the ratio of the capacitance of the capacitor with dielectric to the capacitance of the capacitor without dielectric. So, capacitance of a capacitor with dielectric has the low potential Vd than the capacitance of the capacitor V. So, dielectric constant K, or sometimes we write by epsilon, is equal to V by Vd. Again, we know that the P is directly proportional to the E. If we increase the E value, then force will increase and the polarization will increase. So P is directly proportional to the E. So P is equal to Ke into E. K is a constant and Ke is equal to P by E. Ke is known as the electric susceptibility. Sometimes it is written by the Xi also. So Ke or Xi is known as the electric susceptibility. Next, we will discuss about the magnetic moment. So, up to this is the electrical dipole. Now, we are moving to the magnetic dipole. Magnetic moment, also known as the magnetic dipole moment, is the measure of the object's tendency to align with the magnetic field. So, what is this? There is a, say this is a magnetic field. So, if or there is an iron, we are connecting the iron with the battery. So, this iron has some atoms in it. When it is connected to the battery, the general tendency of the atoms to tend itself such that one will create the north pole and another one is create the south pole. So, all the atoms will move from their position to such a position so that it can be changed into this type of configuration. This is called the magnetic moment. Magnetic moment is defined as a magnetic strength or orientation of a magnet or any other object. Other object means the ferromagnetic material, so that it can produce a magnetic field. The magnetic moment is a vector quantity. The object have a tendency to place themselves in such a way that the magnetic moment vector becomes parallel to the magnetic field lines. As I draw earlier, you can see it are always parallel to each other. The direction of the magnetic moment points always from the south to the north pole of the magnet. As this is a vector, it should have some direction. And what is the direction? The direction is always from the north pole to south pole. The magnetic field created by a magnet is directly proportional to the magnetic moment. The magnetic field created by it depends on the magnetic moment. And the torque is also depends on the magnetic dipole moment into B. B is the flux density. The magnetic moment, in the definition for a current loop, the magnetic moment is the product of the current flowing and the area. So we can write M is equal to I into A. So the unit will be ampere meter square. So the unit will be articulated as ampere meter square. Next, magnetic dipole. Same, it is analogous to the electric dipole. Magnetic dipole is formed when two opposite magnetic charges of the same strength but in the opposite direction is separated by a distance. We are taking it as the L, and the charge we have taken as QM. So the line of joining two lines is known as the axis of dipole. It is similar to the analogous to the electric dipole. Direction of the magnetic dipole is always from the minus QM. Minus QM is nothing but the south pole to the north pole. So we can write M is equal to QM into L. Like there we have wrote here Q into D. Small q is the electric charge. Here we are writing the QM, the magnetic field strength, into L. L is the distance between them. So we have discussed up to this. Let us consider a bar conductor carrying a current I, and they are forming a loop. So we have one magnet and we are connected bar conductor and some current is flowing. So magnetic dipole moment can already we have discussed. This is the M into IA. We have discussed in the previous topic. The magnetic dipole moment is also depends on the M into I into A. If it is an electromagnet and current is flowing like this, then dipole moment depends on the M into IL. And previously we got that QM into L. So QM, both are the definition of the magnetic dipole moment. So if we equal these two, we will get QM into L is equal to I into A. What is magnetization? If there exists a conductor consisting of a number of dipole in its volume, that the magnetic dipole per unit volume is known as the magnetization, M into V. So we got just now QM into L, and the volume is equal to A into L. So we can write QM into A. So what is the unit? Unit is the Worsted per meter square. What are the difference between the electric dipole and magnetic dipole? Magnetic dipole consists of two equal and unlike poles and that do not have a separate existence. One positive, if we are dividing the H2O, H plus, oxygen minus, so they are the different electrons. They are not connected together. whereas the whereas the magnetic dipole has one magnet. It is a connected magnet. The single pole magnet is never exists. So it is the one magnet only. The magnetic dipole does not move while the electric dipole charges can move separately. In the magnetic dipole, inside the magnet they will align themselves, but they cannot move from one place to another place. But in the case of the electric dipole, it can move from one point to another point very easily. Electric dipole and magnetic dipole is that there are two equal and opposite charges in an electric dipole separate existence, whereas the magnetic has the two equal and unlike poles. So what does it mean? In the magnet electric pole, we tell one is the positive charge, another one is the negative charge. But in the case of the electric magnetic dipole, one is north pole, one is south pole. There is no positive pole and negative pole. Nothing. One is the unlike poles. We will tell it's the different pole or unlike poles, opposite poles. But here we will tell opposite polarity, positive, negative. What is that? So definition wise, an electric dipole can be described as a couple of opposite charges plus q and minus q that separated by a distance d. A magnetic dipole can be described as a system of magnetic north pole and a magnetic south pole, as I told here, separated by a small distance d. Electric charge are the two equal and opposite charge. It is the equal and unlike charge. So if we discuss the today's class in a small way, we can tell that. So if we want to discuss the today's class in a small line, we can write that the. So we can discuss that we have discussed today what is polarization, what is electric dipole, what is the type of the dipole moment, what is the susceptibility, and the same thing we discussed about the magnetic field. And again, the third is that we discussed about the difference of the electric dipole and magnetic dipole. So this is my today's class. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.